All right. Come back out to y'all's old homework. Grab yours, pass on the rest. Let's get last night's homework out as well. Or I guess Friday's homework out as well, please. Which would have been H-I-J-K. No, K. H-I-J-K. Cool. What kind of questions did we see on K? 22? 22K, we're there. It was evens, right?
Yeah. I thought it was odd.
I definitely was off.
It was even. No, it was even. It was even.
It was evens. No, I actually looked at my Schoology notes that I had posted from this class, and I had evens.
I thought you said odds.
No, it was odds.
I'm happy to pull up my Schoology thing that's on my website that says evens.
Something is odd about that one.
I definitely remember.
You know, that's okay. I didn't do it.
They would like jump off like
I guess that's what I did. That's one question on the homework. It's really confusing. It was kind of an oddity. It's never too early for time.
January 25th, that would have been Friday. And
It's not on here, it's in the video. I looked on here.
Yeah, in the
It
video.
wasn't on here, it was in the video.
what on here?
It's at the very end where you wrote. Wait,
I didn't have it on here?
It's on here, yeah.
It's on a video.
Where is it on here?
It's not.
I didn't. Come on now.
No, but you wrote a bunch of stuff on the board, and it was also on the board, so.
Yeah, worksheet K, evens. Boom.
This.
Now.
Whoa!
Hey.
Hey.
It's all fun and games, and then Kate drops an F-bomb. We all gotta be like, oh.
Now we gotta record. Now we gotta delete the video.
Yeah, I know. It's been recording at 2 minutes and 7 seconds.
Well, I did odds. So.
All right, well, copy down what you can and call it good. All right, number 22 was asked about. Was that the one after we?
This is some BS. We're in school right now.
I understand.
Stop me doing homework.
What if we all just collectively ditched right now?
You realize if we had a snow day and I was already here, I would have recorded the. I would have come in here and recorded it and said, "All right, you guys gotta watch it at home." I know, because I'm that guy.
No, you're not.
I'm that guy.
No, you're not.
All right.
I wouldn't watch it. I'd just like chill, sleep all day.
All right. So they tell us we have this domain that we gave on this problem. Yes. Let's go ahead and find the range of this. So if I find the range of this, I'm going to take my -1 and 6 and plug it in. If I plug -1 in, I get -6, 12, and 9. Is that okay? I just plug the 1 in for x, so 2 times -1 is -2. Oh, wait, that's -5. Sheesh. Yeah. Can I get the 9 right? 2 times 6 is 12. Yeah. So -5 and 9 are my range of my original. Is that okay? Now, where things get confusing on this is when you look at it going, yeah, but that shouldn't have a restricted domain. You're absolutely correct, but they had restricted it for you anyhow. So you find the range that comes with it. All right, so let's find the inverse. So I get x equals 2y minus 3, add 3, and then divide by 2. All right, so that is the inverse. They would call it f prime at x. That means just the inverse. Okay? My domain of this is then going to be -5 to 9. And my range is going to be -1 to 6. 22?
I know A.
Oh, let's see. A. Here's the answer to A. B, give the range. That's B. C, find the domain. That's C. And then find the range. That's D. Kai? What other opportunities?
Wait, how'd you get the range? Sorry.
Okay, so what I did is they gave us this domain already. So I took -1, plug it in, 2 times -1, -3, got -5. And then plug 6 in. 2 times 6 is 12, 12 minus 3 is 9. 20. All right, find the inverse. Include the steps. Remember to rationalize denominators, type domain and range of using interval notation. All right. Number 20, they gave us f of x equals 1/6 x to the 5th plus 2/3. If it's to the 5th power, this is what the graph kind of looks like. So it goes forever right, left, forever up, down. So the domain of this goes from negative to positive infinity. The range also does. Okay, because it's to the 5th power. And let's find the inverse. Y equals 1/6 x to the 5th plus 2/3. Yay. X equals 1/6 y to the 5th plus 2/3. Bring 2/3 over. Multiply everything by 6. 6x minus 4 equals y to the 5th. So y is equal to the 5th root of 6x minus 4. Being its 5th root, I can have negative numbers, so my domain and range are the same as up there. So negative to positive infinity for both. Nice. Anything else? 18. All right. Number 18. They gave us f of x is equal to 3x to the 4th. And then they tell us, hey, we want to just talk about values that are negative. So this graph entirely would look kind of like this. Bless you. Because we have these values, we're talking about that over there. Okay? So that's the domain. The range of this would go from 0 up to infinity. We're good with that. Is that all right so far? All right, so they already gave us the restriction. And of course, if you wanted to say, all right, well, this means the domain goes from negative infinity to 0 square bracket. Okay, y equals 3x to the 4th. Flip-flop. X over 3 equals y to the 4th. 4th root. Don't forget to do plus or minus because you're doing an even root. So y equals plus or minus the 4th root of x over 3. All right. If it's 4th root, we were just dealing with the negatives there. So I'm going to say that I'm going to deal with the negative here. I guess they probably wanted you to rationalize it. I'm sorry about that. So is that going to be 4th root of 3x over, that's 27, that's got to be. I can't even read that anymore. X over 3. All right, so that's just rationalized, and then our domain will go from is the range of the other one, so 0 to infinity, and then our range will be negative infinity to 0. So just flip flop them. At this point, am I really going to be too worried about this? I'm stoked if you can get to this point. So if I give you this, it might be bonus point. Yes,
I just have a question. Like, I did 23, but just when it says like f negative like 1,
23.
and then like 6.
Oh, put a number? Yeah.
Negative 1, does that just mean the inverse?
Find the inverse, and then once you found the inverse, you plug 6 in for x and get the answer out. Anything else? 12. Okay, find the inverse function if it exists. If it does not, explain why. Okay. Number 12, y equals 2x plus 5. No inverse, why? Yeah,
It's an absolute value, an absolute value.
absolute value. So what? Use some of the terms that we've learned. It is not.
It's not one to one.
It's not one to one. Yeah. So no inverse. So this, no inverse. No f prime at x due to not one to one. Cool. 6. Let's see. We want to verify that they're inverses of each other. So all I'm going to do on number 6 is this. I have, if I want to do f g at x, that means I'm going to take g at x and plug it in. So I'm going to go 1/3 squared. And then I'm going to plug in 3x to the half. And that's also parentheses. So that takes care of that. So that becomes 1/3 times 3x. Reduce the 3, so I get x. So yes, functions. We good? All right, if you would, make sure your names are on those, please. Also, I think, was it I that I said was due today if you needed extra points? So a lot of you have turned I in. I think there was only like 4 or 5 of you that didn't turn it in. So make sure that's turned in. Make sure your names are on all of your work, if you don't mind.
Yo, good catch. Those cat-like reflexes. Yo, bam.
Oh, my bad. I thought Cooper was there. Where's Cooper? You figured out or something? You alright? Clear yet or not? Well, I didn't see you
Thursday, but I was wondering if I could come in and like go over that next test.
Yeah, why don't we, let's wait till you're clear to work. That way, you remember, and you realize you don't have to be doing your homework. I know, I see that you're doing some of it, so don't feel you gotta be doing it. We'll take care of you later. I'll give you all kinds of time to make it up, you know that. I want the gray matter healed. I don't want you to prolong it.
Why is it going gray matter, isn't it?
Because your brain's gray.
Really?
Mm-hmm.
I thought it was pink.
Nope. Gray, and it's the consistency of cream cheese.
Really?
Yeah.
So like, if you would have cut open some dude's brain, it would be like, ew, cream cheese?
Yeah, so right now, our brains are the consistency of cream cheese. So you could literally cut the top of the skull off, take it off, and spread it like cream cheese on a bagel.
Sounds tasty.
I wouldn't recommend it. I'm just saying, that's...
I will use the top portion anyway, it's okay.
Alright. We ready? Recording good? Yay. Ben, you didn't walk in front. Could have waved. Sorry, my bad. Yeah! So, I saw something kind of funny the other day. And I would ask you, if you have your phone, to find this. And you're going to laugh. So you remember the Yanni versus Laurel?
Oh,
Yeah.
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 There's on Sesame Street.
Oh my god.
On Sesame Street. Type in, does Grover cuss in YouTube? And you're going to, and I want to hear if you guys hear it. It was on legitimate Sesame Street. It was on Jimmy Kimmel. Or Jimmy Fallon.
November 24th. Sesame Street.
Man, I mean, what's Sesame Street coming to? Because y'all are here.
What's he supposed to say?
Saying the F-bomb, man.
Wow.
You don't hear him dropping it?
Some people don't. Some people hear, yes, that's an excellent idea. But other people hear some colorful metaphor in there that is used.
Do not hear it, though.
I definitely hear it, man.
I definitely hear it.
I don't hear it.
Some do, some don't. It's funny.
God, you're dumb.
I don't know why. I think it's hilarious that we're at this point in society that I'm here. All right, so anyhow, let's see. Where am I at? All right, so we're gonna start developing understanding radical functions and radical equations. Now, there's something that's you're not gonna like me because of this new concept, but we're gonna go after something called an extraneous solution.
Ooh.
And an extraneous solution is you solve your problem. You're like, hey, here's my answer, and you're wrong because it actually doesn't work. So I know it's good stuff. It's like the math people got together and said, let's goof people up. Okay, so radical functions that contains radicals such as root x, third root x. Radical equation, an equation that contains radicals or rational exponents. All right, solve the radical equation. You need to eliminate the radicals. Okay, isolate the radical and do whatever root you need to it to move it over. And then, or raise each side to the exponent to get rid of the radical. Okay, these are all things that you probably should know. So let's take a look. And then the big thing in red up there says, always check your solutions, okay? And it sounds kind of funny, but yes, at the end, please do double check your solutions because you might come across something that doesn't work. So on this first one, I think you would all be okay with that. What did I just do? Math. Okay, I added 4 to both sides. How do I undo 1/3 x, or the third root of x? What do I have to raise both sides to? To the third. So then 4 to the third is 64. And then double check. If I take 64 and plug it back in, third root of 64 is 4. Is 4 minus 4 is 0.
Heck yeah.
Yeah, so this solution works. Okay? Now, I don't know if we're going to get the extraneous yet. Well, let's take a look. So how would I start getting x by itself here? What should I do first? Divide by 2. So I get x to the 3 over 2 equals 125. Oh, wait. It's raised to the 3 over 2 power, which is the same thing as the root 2 to the third. Or I can just multiply both sides by the reciprocal of this. So I'm going to multiply this, raise that to the 2/3, raise that to the 2/3. Okay, if I do that, that just gives me x over here because you get 6 over 6. 6 over 6 is 1, so x to the first. All right, so what is the third root of 125?
5.
What's 5 squared? 25. Okay? So let's see if 25 works. 25 to the 3/2 power. So 25 square root of 25 is 5. 5 times to the third is 125. 2 times 125 is 250. So this also works. So our solutions are all starting to work nicely. Okay? But again, plug it back in. Just do mental math to see if it'll work out appropriate for you on your problem. May I move on? Okay. Does everyone feel okay that I should subtract 7 from both sides first? Anyone stuck on? Or subtract 12 from both sides first? All right. So I get to this point right here, and I get to that. What do you think?
Yep, yours is.
Okay. Then I'm going to square both sides. And I should put that in parentheses and squared as well. Is that okay?
Yes.
Anyone stuck on that? then add 7. So that's what, 56. Divide by 4. So I get to 14. Seems like such a nice answer. Dude, I get a nice whole number. Now it's just going to wreck you. Ready? All
You
right.
have to plug it back in.
4 times 14.
Oh.
Oh my gosh. It's 28, 56. 56 minus 7 is 49. Square root of 49 is 7. 7 plus 12.
Oh my god.
Nope.
It's like, dude,
We just did it.
I know, we just did the math. And it's like, all of a sudden, it's like, yeah, April Fools, this doesn't work. We have no solution to this problem. You're like, yeah, but you just did it. I know. That's the bad thing.
You must be
You know,
fooling, man.
This is where you're going to find some freshmen out in the hallway and you're going to grab a big old mound of snow and just cream them upside the head. We walk out of class, man, it's because of stirrup, man. He made me do it. You know what? If you guys want, we can go make snowballs and then we'll freeze them and we'll huck them at cars.
Yes.
You guys in?
We should put rocks in the snowballs.
I love it. I love it. So this is called an extraneous solution. So this particular problem has no solution for an answer, even though it works. It's an extraneous solution is a solution that you get when you plug it back into the original. It doesn't work. Okay. All right. Let's try this next one. Before I do too much of this, I'm going to move this over. Is that okay? Anybody stuck with that?
Nah.
Okay. This radical should be a little longer. So from here, I'm just going to go ahead and square both sides. So I get 3x plus 2 equals 4x. Do you feel comfortable with that?
Wait, Mr. Sturp, why do you square it?
To undo, because this is square root, so if I square it, it undoes it. It's a reciprocal. So x equals 2. Another nice, fantastic answer. Let's see if it works. Plug 2 in for x. 3 times 2 is?
Nah. You get like radical x.
So that's 6. 6 plus 2, that's 8. So I get root 8. Root 8 is the same thing as 2 root 2 minus 2 root 2. Did that work?
Yes.
We have a solution. So only some are made to trick you, not all. Oh, man.
But I thought tricks were for kids.
I know. All right, so check work for extraneous solutions. Okay, again, an extraneous solution is the solution you get. And there's sometimes when you solve these, you have 2 answers. One of them works and one of them doesn't. And you're like, are you kidding me? Yeah, I'm not. I'm dead serious. All right. We okay? Okay, so my exponent on the left side is 2/3 power. What's the reciprocal exponent I should do to both sides? 3/2? Is everyone okay with that?
Yeah.
Okay, so that just gives me x minus 2 over here. Fantastic. Okay, the bottom number means square root. So square root of 25 is 5. 5 to the third is 125. Seem good so far? So that gives me x equals 127. Is that right? All right, let's see if that works. Plug 127 in for x. 127 minus 2 is 125. Works good so far. B and I have a 3 down here. That means third root of 125. That's 5. 5 squared is 25. Yay!
Thank you.
Yeah, eventually I'm going to throw another extraneous. And you're like, are you serious? Take a shot. What should I do on number 6? What's the first move? Divide by 3? I like it. Let's see. What is that? That's 3 goes in there 6 times 64 times. Is that right?
Yeah.
Is my math correct? 12. Okay. All right. What should I raise each side to?
2/3.
To the 2/3 power. So remember now the denominator is the root. So those cancel. So that gives me n plus 4. Yay. What is the third root of 64? 4. Good. 4 squared. 16. Bring that over. So subtract 4. So I get to 12. Okay, let's see if this works. 12 plus 4, 16. Square root of 16, 4. 4 to the third, 64. 3 times 64, 192. Oh. He showed us one extraneous solution. When's another one going to show back up on us? This is maddening. Remember that even 2 roots have possible solutions. Okay, I don't think we had... Do we have 2 roots on anything here?
You only get 2 roots if you have like an absolute value.
Ooh, hang on. Hang on. Look at number 5 real quick. I have one of the solutions so far. Why is there a second solution on this one? So the math I would have done from here, x minus 2 to the 2/3 power equals 25. I raised it to the 3 over 2. That's the square root. So now I have the square root. So now I have x minus 2 equals plus or minus 5. 5 to the third, 125. Where did that plus or minus come from? Why did that happen? The denominator of my exponent means it's a square root, so I have a plus or minus component. So then I go x plus 2, so I get 127. Is that right? Let's see. Square root 5, 125.
So 123.
27, and then what's the other one?
123.
Close.
Negative 127.
Negative. Is it negative?
Oh, yeah.
Negative 123? All right. So I agree with the 127. We already did that. But if I take negative 123, plug it in. Negative 123 minus 2, negative 125. The third root of negative 125 is negative 5, right? Negative 5 squared, quantity squared is 25. So here are my 2 solutions to this problem. Okay, so let that sink in for a sec. Why did we have 2 solutions? Because when I raised my exponent, my denominator of my newly raised exponent was even, which means I have to have the plus or minus component.
So if you have like an even, then it will have 2 solutions.
Right. And one of them could be extraneous. On the number 6, the reason I didn't have plus or minus because my exponent became 2 over 3, so my denominator was a 3, which just means I have the one solution.
Nice.
So if one like problem is like extraneous, then the whole thing's wrong, right?
No, so like if one of these didn't work, you'd have one solution and one of them would be extraneous, so you wouldn't count it. Question? No? May I move on?
Yep. You have 4 problems left.
That's it? This one? That one? Okay. Sneeze time. Woo! Woo! Yeah! All right. Okay. Number 7. What should I do to both sides? What should I do to both sides of number 7?
Root.
Root or square?
Square.
Yeah, I'm going to square, but watch what I'm going to do here. I'm going to square that. Is that okay?
Yeah.
Is that good so far? So under here, I'm going to get 2x minus 5. We're done there. And then this gives me x squared minus 4x plus 4. If I FOIL it out, right? Because it's x minus 2 times x minus 2. Good. All right, let's get, I'll have 0 on this side. So I'm going to have x squared minus 6x plus 9. Let me pause there. Can you see what I did? I subtracted 2x from both sides. I added 5 to both sides. What does x minus 6x plus 9 factor down to?
X minus 3 squared.
Yeah, x minus 3, x minus 3, right? Is that right? Okay, which is the same thing as x minus 3 quantity squared. Root. Do I need a plus or minus on this one?
No.
Technically, yes, but it's a 0. 0 is not signless, so I get this. So we find that x is now equal to 3. Does 3 work if I plug it in? 2 times 3 is 12. or 6. 6 minus 5 is 1. Square root of 1 is 1. 3 minus 2 is 1. 1 equals 1. Yay. So the trick on that one is make sure you group the right side. Dude. Ready? Parentheses so far, yes?
Yeah.
I'm also going to put this in parentheses. Is that okay?
Yeah.
Why am I putting that side in parentheses?
Negative.
There's that negative that snuck in on us, little rascal.
We don't need any of that negative.
You got it. All right, so that's just going to give me x squared plus 5 on the left. And then I get x squared plus 10x plus 25. Because I have x plus 5 times x plus 5. So I multiply it all out. Okay. Let's see. I'll make this side 0. So I'm going to subtract x squared. The x squareds are gone. So then I get 10x plus 20.
Yep.
Move 20 over, so I got negative 20 equals 10x. So x equals negative 2. Is that okay? This has got to be extraneous, I think. I don't know. All right, plug it in here. Negative 2 plus 5, that's 3. Cool, I like it. Negative 2 squared is 4. 4 plus 5 is 9. Square root of 9 is 3. This negative comes along, so negative 3 is equal to 3.
Hey.
We didn't discover the greatest kept secret in math, did we? No, this is an extraneous solution. So this answer actually has no solution to it. And negative really came back to kind of haunt us. Finally, we get to see another extraneous solution. I feel so much better about myself. Yeah.
When you would square negative root x squared plus 5, would that make it a positive x squared plus 5?
Because I grouped the whole thing, so then I have 2 of these.
Okay.
So I'm multiplying it, that's why the negative drops, and then you just get the x squared plus 5 underneath.
Okay.
Last slide, right?
Yeah.
Woo!
2 more questions.
Alright. Let's see. Subtract 9 from both sides. Still with me?
Yeah.
Square, square. What'd I do? Who's pitting? Look at their pants down. I don't need to turn around.
That's gross, bro.
I'm sorry. What is that? Negative 31? I get 31 over 6? Ew. So if I plug 31 out of 6 in there, that becomes, so excuse me, negative 31, right? So 40 minus 31 is 9, square root of 9 is 3, 3 plus 9 is 12.
Negative, so.
Or I'm seeing a negative. 31 over 6 plugs in right there. This becomes 31, right?
Yeah.
40 minus 31 is 9. Square root of 9 is 3. 3 plus 9 is 12.
I thought it was negative 31.
Where are you seeing a negative? Oh, it was here, but I divided both sides by negative. Negative over negative is positive.
Okay, cool.
All right, last one. Yay! 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 I'm going to raise it to the 3 over 2 power. 3 over 2. So over 2 means you're doing root of an even of both sides. So you're going to get a plus or minus. So I get plus or minus. What is the square root of 4? 2. What's 2 to the third? 8. So subtract 1. So minus 1 plus or minus 8. So I'm going to get negative 1. That's going to give me 7. And negative 9. Let's make sure they both work. Okay, let's plug them in. 7 plus 1 is 8. 8 to the 2/3 power is 4. 4 times 3 is 12. 12 minus 1 is 11. So this one works. Plug negative 9 and negative 9 plus 1 is negative 8. Negative 8 to the 2/3 power is, negative 9. 2/3 power, so negative 8, negative 2. That's 4. 4 times 3 is 12. It works. They both work. Yay. Kate, what should we do?
Evens.
Y'all heard it?
Nice.
Worksheet 8L. Kate, what is it again?
Evens.
Alright, so just so you know this week, we have 8L. Tomorrow is kind of a review day. We'll start with trig on Wednesday.
I love God.
Ooh, trig's awesome. And then quiz G through M on Thursday, Friday more trig. Or we'll say more on trig. I said moron.
Trig. Wait, we're taking a quiz.